All right, section 5.3 is about writing linear equations in point-slope form. Sometimes I like to ask my students, if you could only have one pair of skis, which pair would it be? Your slalom or your GS, your downhill, super G? Anyway, if I could only use one form, it would be point-slope form. So just to remind you, this is slope-intercept form, y equals mx plus b, where we're looking for the slope and the intercept. This is point-slope form because there's still our slope, m, and then there's our point, x1, y1. But this is the entire form of the equation. And remember, we're writing a relationship between x and y. So in slope-intercept, x and y are in black. The relationship is slope and intercept. In point-slope, the relationship is between x and y. And I can describe the relationship between another point and a slope. So write an equation of point-slope given a point and the slope. So the first thing I like to do is label my point x1, y1, and I'm going to notice that my slope is 2. So it's y minus y1 equals m times x minus x1. So I simply plug in my y1, being careful to note that I'm subtracting a negative 3. My slope is 2, and the x-coordinate of my point is 4. So I'm going to tidy this up, and I'm done. That is point-slope form. There's my point, there's my slope. Let's do it again. This case, m is 7/3, so it's y minus y1 equals m times x minus x1. So it's y minus, again, a negative 9, x minus a negative 3. So I get y plus 9 equals 7/3 x plus 3. So what I want you to see, since the formula is y minus y1 and x minus x1, notice here I can see that my y must have been a negative 3 because it changed to plus. My x must be a positive 4 because it didn't change. Down here I can see my y must have been a negative 9 because it changed to plus. My x must have been a negative 3 because it changed to plus. That's going to come in handy in a moment. So here we are being asked, I have these on top of each other, I don't usually do that. Here we are being asked to graph this equation. Well, if we notice, this is my x1, y1, and this is my slope. And I'm just going to remind you that it's y minus y1 times x minus x1. So my x1 must be positive because the sign didn't change, and my y must be positive since the sign didn't change. And then I like to write my slope as a fraction, rise over run. So I'm going to start by plotting 1, 2, 3, 4, 5. And plotting that point and labeling it gives you a, essentially notes the scale. There really should be scale here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, that gives some indication of scale. And then if I'm going up 3, 1, 2, 3, and over 1, there's my next point. Or I can go down 3 over 1. That makes it a little easier. And I didn't plan this out very well. There's my line, using my point and this idea of slope. Let's try it again. So y minus y1 equals m times x minus x1. So I can notice that my x was positive, but my y must have been negative in order to change to a positive. And then my slope is down 5 over 2. So I'm going to start by doing 3, negative 4. I'll indicate scale. 3, negative 4. and then I go down 5 and over 2, or I can go left 2 and up 5. The negative can be seen for either coordinate. I can go left 2, up 5, or I can go down 5, right 2. You should note that that's negative, so if somehow your line was going in a positive direction, you would realize that you did something wrong. So use the point and the slope to graph. And then we're going to write equation given 2 points. And again, they might be given to you on a graph. There's your coordinates. They might be given to you as coordinates. I don't believe they give these to you as function notation, but quick quiz, how would I write that as function notation? When -1 came in, 4 went out. When 5 went in, -2 came out. So given 2 points, I can use either point for x1, y1. I believe the instructions are going to tell you use the point to the right or use the second point. I don't think it really matters, but I'm going to label these. It's just when you check your answer, what it looks like, whether it matches the answer sheet or not. So the trick here is that I actually have to calculate my slope this time around. So m is y2 minus rise over run, the change in y over the change in x. So I have a -2 minus a 4 over a 5 minus a -1. So that gives me a -6 over 6, which is -1 over 1. That's a nice slope to work with. And I'll say maybe they said use this point. So I'm going to say y minus a -2 equals -1 times x minus 5. So tighten this up. And there's the equation for my line. If you had used the other point, it would still be the same thing. I'd have y minus 4 equals -1 times x minus a -1, and I'd have y minus 4 equals -1, x plus 1. These are the same line. It's just that they'll tell you which point to use, and then your answer will match their answer sheet. And you don't need to do this. I'm going to do it in blue, but I'm just going to show you how that is the same line. So if I distribute -x plus 5, and then I subtract 2, I get y equals -x plus 3, right? -1x plus 3. If I do this one, y minus 4 equals -x minus 1. If I add 4 to both sides, I get y equals -1x plus 3. So note, they are the same line. All right, finally, we're starting to make some connections. Suppose I have a table of values. This is why we really use this linear equation stuff. Maybe I'm trying to describe some kind of pattern. This has to do with some photo prints you can order online. If you get 1 print, it costs $1.98. If you get 2, it costs $2.47. If you get 5, it costs $3.94. And if you get 8, it costs $5.41. The first question they say is, why is it linear? So if it was linear, right, this would have to go up in equal increments. So I can check that if I find if I find the change in y, 2.47 minus 1.98, that's 0.49. So that's 0.49 over 1. If I do this, 3.94 minus 2.47, that's 1.47, but that's divided by 3, right? Because the change was 3. And if I do the division, that equals 0.49 over 1. So I would have to find the same thing here. So why is it linear? Because the rate of change is constant. That's why it's linear. And it says to write an equation. Well, what do I need for an equation? I need a slope and a point. So I just calculated my slope. It's 49 cents for every 1 print. And using a point, it doesn't really matter which one I'm going to use. Let's use 2, 247. So I'd have y minus 2.47 equals 0.49 times x minus 2. And that would be an equation for my line. And again, you could distribute if you want to tidy that up. And then it says find the cost for 10 prints. So y minus 2.47 equals 0.49 times 10 minus 2. And this is 8, so 0.49 times 8 is 392. Then I'd have to add the 247. Oops. 639. So it would cost 639 for 10 prints. So a good example of, we did word problems. Now you have a table. Why is it linear? It must be a constant rate of change. Find that slope. And again, be careful here because in this case, if you had used these 2 points, it'd be $1.47 for 3 prints. So you'd have to do 147 over 3. Same thing here. You'd have to, I'm assuming this would be the same thing because that's 3. So there's your slope. Use any point you want. That gives you the equation. You could change it into slope-intercept form if you wanted to. Then just plug in your input, number of prints, and find the cost. All right, that's section number 3. Getting it done.